Welcome back, students. This is the session 1 from the playlist of NEET Physics Part 2. The chapter is Electric Charges in Field, and the topic for this session is electric flux. So, based on this topic, I have taken one question which is written on this board, and this question was asked in the CBSE All India Pre-Medical Test. This question was asked in the year 2007, and the question here is, a hollow cylinder has a charge Q coulomb within it. So this is a hollow cylinder, and this is a charge Q which is enclosed inside the cylinder. And this diagram, this figure was given along with this question here. If phi is the electric flux associated with the curved surface B, this is the curved surface, B is the curved surface of this hollow cylinder, A is the curved surface of this hollow cylinder, and C is the curved surface of this hollow cylinder. So phi is the flux associated with this curved surface B. So here we have to find the flux linked with the surface A. And we have been given 4 options here. So, and we have to find the correct one. So before solving this question, I would like to just go through these 4 bullet points which I have written on this board. So here, first thing is that the topic is electric flux. So I would like to just define what electric flux is. So electric flux is a measure of the intensity of the electric field through a given surface. This is the definition of the electric flux. Second point is, the electric flux is taken as positive if it is leaving the surface. For example, let us consider one surface here. Let us say this is the curved surface A. Now, if the electric flux is leaving the surface, that is, if it is directed away from the surface, as pointed by this arrow, then the electric flux is taken as positive. Second point, if the electric flux is directed into the surface, then it is taken as negative. For example, let us say take the case of this curved surface C. So if the electric flux is directed as indicated by this arrow, that is, it is directed into the surface, then in that case it is taken as negative. Now, electric flux is the measure of the intensity of the electric field through a given surface. So, the electric field is generated by the charge. So, here there is a charge. A positive charge will generate the electric field in the outward direction. That is, the direction of the electric field due to a positive charge is directed outward as indicated by this arrow, whereas the electric field due to a negative charge is directed inwards as indicated by this arrow in this diagram. Here this is a negative charge, so the electric field is directed inwards, that is towards the charge, whereas in the case of a positive charge, the electric field is directed outward, or you can say it is away from the charge. So now, in this case, we have a positive charge in the hollow cylinder. So because of this, because it is a positive charge, so therefore the electric field lines, they will be directed away from the charge as we have just discussed. So this will be the direction of the electric field as indicated by these arrows. That is, the electric field will be directed away from the charge, or you can say it will be directed outward. So now, since it is a positive charge and the electric field lines are directed outward, therefore the electric flux through this curved surface A, C and B will be directed outward, or it is directed away from the surface. So since it is directed away from the surface, or you can say since the electric flux is leaving the surface, therefore the flux due to this positive charge which is lying inside this hollow cylinder will be positive for all these three surfaces. So the total flux will be equal to the flux due to the flux which is linked with this curved surface A, the flux which is linked with this curved surface B, and the flux which is linked with this curved surface C. So let us say the flux linked with this curved surface A is phi A. So this will be equal to phi A plus, let us consider that the flux linked with this curved surface B is phi B. So it will be phi B plus phi B, and the flux which is linked with the curved surface C, let us say it is phi C. Since the electric flux are leaving the surface, or you can say since they are directed outward from the surface, therefore all these three flux will be taken as positive. So first thing is this. Second point is here we will be using the Gauss law. Now the Gauss law states that the total flux linked with a closed surface. The total flux linked with a closed surface is equal to the total flux linked with a closed surface is equal to Q divided by epsilon naught, where Q is the total amount of charge enclosed by that surface. So here the surface is a hollow cylinder. The charge enclosed by this hollow cylinder is Q. So if the total flux associated with this hollow cylinder is phi, then phi is equal to Q upon epsilon naught, where phi is the total flux, total electric flux associated with the hollow cylinder. Now we have also got one. So this is the equation number 1, and let us say this is the equation number 2. This is the equation number 2, let us say. Now the total flux is equal to phi A plus phi B plus phi C, and this is also equal to Q upon epsilon naught. So I will get one. So I am getting one equation from these two equations, that is Q upon epsilon naught is equal to phi A plus phi B plus phi C. Now the flux linked with the curved surface A is equal to the flux linked with the curved surface B, because the cross-sectional area of this curved surface A is equal to the cross-sectional area of the curved surface C. So we can simply write this equation as phi A. Now the phi B is if phi is the electric flux associated with the curved surface B, so phi B is equal to phi plus. Now since the flux linked with this curved surface C is equal to the flux linked with the curved surface A, because the cross-sectional area of both these two surfaces are equal, so I can substitute this phi C by phi A. So finally what I am getting here is Q upon epsilon naught is equal to 2 phi A plus phi. So this is the equation which I have got, and now I have to simply solve this equation and we will get the answer. So from here, it is Q upon epsilon naught is equal to 2 phi A plus phi. So from here, the value of 2 phi A is equal to Q divided by epsilon naught minus phi, or we can say that the flux which is associated with the curved surface A is equal to 1 by 2 Q divided by epsilon naught minus phi. So the correct option is A here. Now the most important thing here which you have to remember in this question is that is the electric flux is taken as positive when it is leaving the surface, and it is taken as negative when it is entering a surface. Second important point, the electric field lines due to a positive charge is directed outward, and the electric field lines due to a negative charge is directed inward. So these were the few important points which needs to be remembered while solving these type of questions. And so I hope you have understood the solution of this question. And in the next session, I will be taking up the questions from this chapter, that is the electric charges in fields, but the topic will be different. So till then, have a nice day. Bye.